Okay, Assalamualaikum warahmatullahi wabarakatuh and hi everyone. Waalaikumsalam. Khair. Morning Andrew. Aisha. Morning Pechong. Waalaikumsalam AB. Good morning Jeannie. Waalaikumsalam Mai. Waalaikumsalam Ellie. Waalaikumsalam Sam. Amira. So how are you guys today? Have you had your breakfast? Okay, so I hope you have, yeah. Okay, because breakfast is important. Okay, so to fuel your day. Alright, okay, so today we are going to finish topic 9. Okay, so as you can see from the screen here, okay, so we have about 2 learning outcomes more to accomplish. Okay, and then as soon as we finish this topic, so I hope you can start doing exercises, okay, and try to solve problems on discrete and random variables. Okay, again, okay, so I always remind you this, topic 9 is the largest mark contributor. So this is the topic that you need to pay most attention to, alright, in order to score A for your maths, okay? So I hope you can stay with me, alright, throughout the session. Okay, and again, if you have any problems or any questions, alright, so you can write in the live chat, yeah? Okay, so now let's begin. Okay, so today we are going to, we had found the cumulative distribution function. So now, okay, let's discuss on how to find the median. Okay, so you can see here. Alright, so these are the things that we're going to accomplish today. Right, okay, so you can see here. Okay, so what is median? Okay, so now this is it. Okay, so there is one value that is particularly important in the cumulative distribution function. As okay, we learned in the earlier chapter, so the median was defined as the middle value, okay, which okay with exactly half the data lying below that value and half lying above that value. So in the context of a probability, okay, so let's say this one is when we talk about topic 6, so if you arrange the data in ascending order, okay, so let's say you have this first observation, second observation, so on and so forth until your nth observation. So basically how to locate your median is by finding the middle value, okay, so the middle data. So that is okay the definition of median in topic 6. Okay, so again, because this topic is very much related with topic 6, okay, so now in the context of probability density function, so the median will be that point below which the area is 0.5 and above which the area is also 0.5. Okay, why? Because we know, right, total of probabilities is 1. Okay, and also when we talk about this continuous random variable, okay, we talk about the total area, right? So total area, okay, below the function here is 1, yeah. So this is what we call as total area. Okay, so total area below the graph. So when it comes to the median, so median is a value which divides the area under the curve into halves. Okay, so as you can see from this diagram, okay, so this is a symmetrical function here. So once this function is symmetrical, okay, so now you can see that m is basically a value which cuts the graph, or which cuts the area into half. So which means we can say that here the area under the graph is 0.5 and this is 0.5. Okay, again, I need to remind that median is the value which divides the area into halves, yeah. Okay, so in simple words, okay, so median is a value, okay, so is a value which divides, okay, area into halves, okay, into halves. Okay, and this is median is and for this continuous random variable, so median is basically a value which divides the array into halves, and median is not middle point between A and B. So this is not middle point between A and B. Okay, so median is not midpoint. Okay, median is not midpoint between A and B. Okay, so this one thing that you have to know. Okay, because again, okay, this one coincidentally, because we have this graph to be symmetrical. Okay, what if you have a function or a graph which is not symmetrical? So in this case, alright, so this is your PDF function fx. Okay, so let's say your graph looks like this one, where this is your A and this is your B. So basically the function is defined from A to B only. Okay, so again, median is not a middle value or not a midpoint between A and B. Median is again a value which divides the area into half. So you may notice that because this is not symmetrical function, so you may notice that the area might be, so the 0.5 might be located here. This one is the area 0.5. So you can see in terms of the position of M between A and B, so you can see that M is closer to B rather than the A. Okay, so in this case, it's not necessarily B, M to be the midpoint between A and B. Okay, it's just that M is a value which divides the area into halves. Okay, so this is one concept that you really need to understand. Yeah. Okay, so now let's see example. So example 1, okay, X is a continuous random variable with probability density function, okay, given as linear function, and the function is only defined from 1 to 3. So the question says find the cumulative distribution function. Okay, so again, as what we discussed before, so if you are required to find CDF of a PDF, okay, or if you're required to find CDF of a continuous random variable, so my advice is please draw a number line. Okay, so once you draw the number line, so you can see that, okay, the function is defined, okay, between, okay, from 1 to 3. So you label the function here. So 4 minus x is defined here. Then what about the rest of the number line? So you can see here, there is no function defined, right? So the function here is 0. And here also there's no function defined, so the function is 0. So once you can once you see the number line, you can see clearly that, okay, between these two numbers there are 3 different regions. Okay, so this is how to guide you in order to find your cumulative distribution function. So we divide into 3 different regions. Okay, so now you can see here for the first region where x is less than 1. Okay, so again the concept of CDF. Okay, so this is the general formula. I write down the general formula. It's negative infinity until x, and you integrate the PDF. Okay, so now so which means here in the first region, we are going to put the x in the first region. Okay, so now the formula is negative infinity until x, and we integrate the function, the respective function defined. So you can see that the value is 0. Why? Yeah, because this makes sense, because we know that the first, the cumulative distribution function will always begin with 0 and it will always end with 1. Okay, and then for the second region, okay, so you can see here, okay, for the second region, okay, so we are going to put the x in the second region. So this is where the x is. And from negative infinity, okay, to reach this x, you can see that it crosses 2 different regions. So once it crosses 2 different regions, so it will involve 2 different functions. So that's why clearly you can see here, we have 2 different integrals. Okay, so the first integral is from negative infinity until 1, and the next one is from 1 until x. Okay, so we integrate the function, and you will get a function. Why? Because we are looking for CDF. We are not looking for a value. Okay, so that's why we have a function here. Okay, and then lastly, okay, for the third region, okay, so this is the third region. Okay, so where we are going to put the x, so the x will be here, okay, in the third region. So you can see here, okay, from negative infinity to reach our x here, it will cross over 3 different functions, right? So this first function, second function, third function. So once it crosses 3 different functions, you can see there are 3 different regions. Okay, and again, I just need to make a correction here. This is supposed to be x, yeah? Okay, because again, okay, we recall the formula of CDF, yeah? It has to be, okay, from negative infinity until x. Okay, but in this case, we cannot have only one single integral, because, okay, we have 3 different functions, yeah, 3 different functions involved for the 3 different regions. So that is why we need to write down all the three different integrals. And you will notice that the function is going to be 1 because that's the final region that we have. And you can see clearly here CDF will always begin with 0 and end with 1. Okay, so once we obtain our CDF, okay, so always remember, okay, whenever you come across this kind of question in exam, make sure you circle the word function and you write down the word piecewise. Okay, so final answer has to be given in piecewise function. Okay, so clearly you can see from this. Okay, so the final answer has to be given in piecewise. So that means you cannot stop here. Okay, so you cannot stop here. Okay, so you need to finalize your answer in piecewise function. Okay, so that's one thing that you need to remember. Okay, so then after we obtain the cumulative distribution function, what's next? Okay, so we need to obtain the median. Okay, so again, how to find median? So median is a value which divides the area into halves, yeah? Okay, so median is a value which divides the area into halves. Okay, so how are we going to find our median? Okay, so now you can see here. Okay, so just like this grid, so median is the when the cumulative probability, so this is what I call as cumulative probability. Okay, or because we are talking about continuous random variable, this is the area. Okay, so the area under the graph. Okay, so the area under the graph is 0.5. Okay, so now how we obtain our median? And because, okay, in this case, our cumulative distribution function, okay, only involves with one type of function. Okay, this one 0, this one 1. So we know that our median does not lie here. It doesn't lie here. So we know that the median is located somewhere, okay, from 1 to 3, somewhere between 1 and 3. So now how are we going to find our median? Okay, so what we're going to do is we're going to substitute the m or the median into the function here. Okay, so now once you substitute your m into this quadratic function, so you will, okay, you equate to 0.5, and then this is all about solving the quadratic equation. Okay, and you notice that, okay, solving quadratic equation, we have three different methods. First is factorization, second is completing the square, and third is by using formula. And because in this case the factorization doesn't work, so we are going to apply the formula. So this is the formula, and you will notice that there are two different values that we have. But again, okay, you can see that logically the CDF is defined, okay, between 1 and 3, right? From 1 to 3. So this is the CDF, negative 1 over 8 x squared minus 8x plus 7. So if median is located, okay, between 1 and 3, so we are going to accept this. So the logical value is going to be 1.76. Okay, so we are going to reject this value because this is outside the region. Okay, because this doesn't make sense. Okay, because the median has to be between 1 and 3. Okay, so this is the method of finding median using CDF. Yeah, so using CDF. Okay, you can also find the median using PDF. Okay, how are we going to find the median using PDF? Okay, if you want to use PDF, so you are going to perform integration. So whereby if you are going to use PDF, so which means you have to integrate the PDF function here. Okay, because again, we know the median is somewhere here, which divides the area into half, right? So this area will be 0.5 and the other area here will be 0.5. Okay, now how do we know the value of m? So you are going to have the integral. Okay, so again, we begin with this. So the cumulative probability is 0.5. Okay, and now we know that, okay, we integrate, okay, from 1, because the PDF is defined from 1 to 3. So we integrate from 1 until m, and we integrate the PDF. So the PDF is 1 over 4 times 4 minus x. So 1 over 4 times 4 minus x dx, and we equate to 0.5. Okay, so integrating this function will give you, okay, 4x minus x squared over 2 equals 1 over 2. Okay, so I okay, I transform the 0.5 to be 1 over 2. Okay, then the limits here are 1 and m, right? Okay, so now, okay, we substitute the limits. So by substituting, the upper limit will give us 4m minus m squared over 2. And then minus with, okay, we substitute the lower limit. You have 4 minus 1 over 2. Okay, and then you equate to 1 over 2. And eventually, you'll be getting the quadratic equation, yeah, more or less the same, yeah, so, which is exactly the same as this quadratic. And by solving the quadratic, will give you actually the same answer. Okay, solving the quadratic equation. Okay, quadratic equation. Okay, will give you two values of m. So one is m equals 1.76 and the other one is m equals 6.24. But again, logically, because m is located between 1 and 3, so this is the value that we're going to accept. Okay, you just underline and put the hash symbol, while this value you just, okay, reject. Okay, so for any value that you need to reject, you please list down, yeah. Okay, or please write down the word rejected, or else the examiner will assume that you accept both, huh? Okay, so this is how we find median using both functions. One is CDF and one is PDF. Okay. Alright, so now, okay, and one reminder that I need to remind you also. Okay, so reminder. Okay, so there's no such thing. Yeah, in this, okay, for this particular continuous random variable, we are not going. Okay, so there's no such thing as integral of, okay, CDF. Okay, we will not be integrating CDF and we will not be differentiating PDF. Yeah? Okay, kenapa? Because this is not the correct concept. Because, okay, in order to obtain the cumulative function, you need to integrate, the function that you need to integrate is the PDF. Okay, and the opposite is when you need to obtain this PDF from CDF, you are going to differentiate the CDF. Okay, so again, okay, you can see that here, okay, again, there's no such thing as integrating the CDF. Okay, and again, there's no such thing as differentiating PDF. Kita takkan differentiate PDF dan kita takkan integrate CDF. So, tolong ingat dua konsep ni. Okay, because again, the CDF is coming from the integration of PDF, while the PDF here is coming from differentiating the CDF. Okay, so I hope this is clear. Alright, okay, so now, so let's discuss next. Okay, so obtaining the probability density function. So this is what I meant just now. So in order to obtain the PDF, we are going to differentiate the CDF. Okay, so now let's see the example. Okay, example 1, we are given the cumulative distribution function of a continuous random variable. So now the question says, find the probability density function. Okay, so in order to obtain the PDF, so this is the general concept. Okay, so you need to differentiate the CDF. Okay, so now how to differentiate? So you need to recall all the differentiation principles back in semester 1 topic 9. Okay, so these are all prior knowledge that you need to acquire, okay, in order to sit for the exam in the second semester. Okay, so now how are we going to find the PDF? So we are going to go through each of the regions here. Okay, so because there are 3 regions, okay, 3 different regions, so we are going to, okay, differentiate each and every function here. Okay, so now let's see the first region. So this is the first region. Okay, so we are going to differentiate this function. So the PDF is going to be the derivative of 0, which is 0. And then for the second region, okay, so how to obtain the PDF? So again, the PDF is the derivative of this function, x cubed over 27. And okay, we are going to apply the power rule. Power rule means, okay, we bring the power to the front and then the power reduced by 1. Okay, so then we will have x squared over 9, right? And then for the third region here, okay, so x greater than 3, we're going to differentiate this function. So differentiating 1, okay, because it's a constant, so you will get 0. And again, I need to remind you because we are looking for function. So when you come across this kind of question in exam, make sure you write down this word. Function means it has to be given in piecewise. Alright, so that means we cannot stop here. Okay, so you need to finalize the answer in piecewise. Alright. Okay, so because we have two different functions with zeros, right? So you can just combine them and you put otherwise. Otherwise means for the rest of the number line, okay, the functions are zero. Okay, you see that? Okay, from 0 to 3, the function defined, so the PDF is x squared over 9. Okay, the otherwise is actually means that, okay, for the rest of the number line, okay, except for this region, so the functions or the PDF are going to be zeros. Okay, so that is the meaning of word otherwise, yeah. Okay, so now next, okay, sketch the function. So we are going to sketch the PDF. All right, so the y-axis here is the okay, the representation of the PDF. Okay, because you can see clearly here, this is the graph of quadratic, right? Okay, so again, in order to sketch graph, okay, so again, all your prior knowledge in semester 1, in particularly in topic 5, function and graph are needed, yeah. So you need to know how to sketch graph, huh? Okay, so in this case, because the function is quadratic, so it's going to be a small shape, and because the function is only defined from 0 to 3, so it's going to be only half of the quadratic function. And let's say, okay, because the question stops here, okay, and let's say if I add one question here, C, okay, find the mode. Okay, so again, in order to find mode, okay, for discrete random variable, we just take the x with highest probability. But now when it comes to continuous random variable, because we are only given the function, right? So, okay, based on this function, algebraically, we cannot really tell the highest probability unless we sketch the graph. Okay, so in order to find the mode, so again, we need to sketch PDF graph. So we need to sketch PDF graph. Okay, so and okay, after we sketch the PDF graph, we find the highest peak. Okay, we find the highest peak. Okay, so clearly from this, you can see that the highest peak is when x is 3, right? So you can conclude in this case, the mode is equal to 3. Okay, so I hope now you know how to find mode now for continuous random variable. Okay, so now let's see example 2. Okay, we are given the CDF. All right. Okay, so find the values of constants A and B. Okay, so you can see clearly here. Okay, there are A and B as unknowns. So we do not know what the values. Okay, so the question says find the values. Okay, how do we do that? Okay, again, my advice is, okay, for continuous random variable, you always draw the number line. Okay, so the tip is, okay, for discrete, okay, in order to solve topic 9 question now, for discrete, always have table. Okay, while for continuous, so my advice is always have number line. Okay, when you have number line and when you label the number line with the respective functions, then you can clearly see which function is defined for which region. Okay, and then from there you can minimize the mistake that you may do. All right. Okay, so now how do we solve this question? The A question. Find the values of A and B. So once we draw the number line, okay, we can see clearly. Okay, we can see clearly that at this particular value of x, -2, so there are two functions defined. Okay, even though you can see that this one is empty circle and this one is dense circle, but it does not really matter. Why? Okay, because we had discussed this before. For continuous random variable, okay, the equal sign does not really matter. So the equal sign does not really matter. Okay, because okay, when it comes to finding probability, okay, for CDF, we are looking for the area below the graph, right? So, okay, yeah, the equal sign does not really matter. So you can see clearly from this. Okay, let's say if you want to find probability for continuous random variable, okay, so even though you have equal or not equal, so it does not really matter. So actually we are looking for simply the area below the graph. Okay, so that is why, okay, in this case, Okay, so coming back to our example here. Okay, so even though you have done circle here and empty circle, so it does not really matter. What we know is actually there are two functions defined at this particular value of x. So the same thing applied here. So at this particular x equals 0, there are two functions defined. So what can we do is, okay, when we substitute the value 0 into this function, the value is going to be exactly the same with this when we substitute the value of 0. Okay, so once you substitute 0 into this function, you will obtain f0. And here, when you substitute the value of 0 into this function, also you will have of f0. So then what do we do next? We can simply equate the two values here. Okay, so now, okay, let's see here. So for the region -2 until 0, okay, so this is the region -2 until 0, I substitute the value of 0 into the function here. Okay, so you will get 1/12 times 2 plus 0, which is 1/6. And next, okay, for this region 0 until 4, okay, so I substitute 0 into this function a plus x over 6. So when we substitute 0 into this function a plus x over 6, so it's going to be a plus 0 over 6, which is a. And because these two are both f0, so in terms of values, they are going to be equal. So what can we do? We can just compare these two and we can simply equate these two. So we can deduce that a is equal to 1/6. Okay, so that's one thing. And now how to obtain the value of b? Okay, so you can see here that at this particular value of x, 4, so there are two different functions here. Okay, again, even though this one we have 10 circle and this one is empty circle, but it does not really matter because this is continuous random variable. So now, when you substitute the value of 4 into this function, the value is going to be exactly the same when you substitute the value of 4 into this function. Okay, so what we're going to do, okay, so you can see that for this particular interval, 0 to 4, okay, when we substitute the value of 4, so, okay, because since a is 1/6, so we can just replace this a with 1/6, yeah? So, okay, you substitute the value of 4, so you have 1/6 plus 4/6, yeah, because this is actually x, right? So 1/6 plus x over 6. So because the x is 4 here, so we put 4/6, so we get 5/6. And next, okay, we are going to substitute 4 into this function. So, okay, for this region, okay, so we are going to find the f4 where, okay, it's going to be b plus, because this is x over 12. So we just replace the x with 4. So we'll have b plus 4/12, which is b plus 1/3. And again, because both here are f4, so in terms of values, they are going to be equal. So now what can we do? We can just equate these two. So you can conclude that b is 1/2. Okay, so after we obtain the values of a and b, you can just substitute into the function, okay, into the cumulative distribution function. All right, okay, so then what's next? Okay, so we see here for the b part, okay, the question says find the probability density function. So again, okay, the question asking for function, right? So it has to be in piecewise. Okay, so now how do we do? Because we need to obtain the PDF, so the general concept is that in order to find PDF, it's the derivative of CDF. Okay, so we are going to perform differentiation, yeah? Okay, and because we have 4 different regions here, so you can see that, all right, so we are going to have 4 times, sorry, not 4 different regions, it's 5, right? Okay, so because we have 5 different regions, so it's going to be 5 times of differentiation that we're going to perform. Okay, so you can see for the first region, the PDF is going to be the derivative of 0, which is 0. And then, okay, for the second region, so the PDF is going to be the derivative of, okay, this function. Okay, and please bear in mind, okay, this is the function, right? The second function. So I just expand, yeah. So 1/12 we multiply in, so we will have 2/12 plus x over 12. So which is 1/6 plus x over 12. So differentiating this linear will give you a constant, right? Okay, so again, I hope that you don't get confused, huh? Okay, between differentiation and integration. When it comes to the differentiation, the power going to be reduced by 1. Okay, so and the differentiating linear will give you a constant function. Okay, then next for the third region, we're going to differentiate this function. Okay, and because we have obtained the value of a earlier, so you just replace this a with 1 over 6. So now differentiating 1 over 6 plus x over 6 will give you 1 over 6. Okay, and now next, okay, because we have got the value of b just now, so b is 1 over 2, right? So we replace here. So in the fourth region, okay, so the PDF is going to be the derivative of this linear function, and the result is going to be a constant. Okay, and finally, in the last region, okay, in order to obtain the PDF, is the derivative of the 1. So we will get 0. Okay, so now you can see that there are these functions of PDF, and again it has to be given in piecewise. So listing down each of these, okay, so you see this is 1 over 12. Okay, we transfer the value here. 1 over 6, we transfer the value here. Okay, once you transfer the value, you simply copy down the range here. You bring it here. Okay, so the 1 over 12 here is for the interval negative to 0, right? So you just copy down. And then this 1 over 6 together with the interval 0 to 4, you just copy down. Okay, and then here 1 over 12 is for this region, 4 until 6, and we just copy down. And okay, because the 0 here, they appear twice, so you just put 0 and just put otherwise. Okay, it just explains that for the rest of the region, okay, on the number line, except for these three, the functions are going to be 0. Okay, so we are done with the PDF, yeah. So again, the reminder is whenever you are required to find the function, always give the answer in piecewise. All right, so now next, okay, the question says find the probability. Okay, so in order to find the probability of x, yeah, greater equal 3 and less than 5. Okay, so again, please bear in mind this is probability for continuous, right? So actually the equal sign does not really matter lah. Okay, but then yeah, because we do have this, so we just copy down the question. So we are looking for probability when x is greater equal 3 and less than 5. So in this case, you have two different methods, yeah, that you can use in order to find the probability. So first, I show you how we can use the PDF. Okay, so okay, now how to use PDF, which means we need to find the area, right? Area below the graph from 3 to 5. But then you will notice that we have two different integrals here. Why does that happen? Because okay, from 3 to 5, okay, so you can see that okay, this is the CDF, right? So this one is the CDF. Okay, so if I draw this, so this is the PDF, huh? So this is the PDF. Okay, now we are going to use this PDF. So if we label, okay, if we draw a number line, so negative 2, 0, 4, and 6. Okay, now we need to find the probability of x greater equal 3. So you can see here, 3 is located between 0 and 4, while 5 here is located between 4 and 6. So in order to find the probability, or in other words, the area below the graph from 3 to 5, which means, okay, it will cross over two different functions, right? So how to find the area here? So that's why we have two different integrals. Because, okay, for the region 0 to 4, we have the function 1 over 6. And for the region 4 to 5, we are going to have this function 1 over 12. So that is why we do have two different integrals, yeah. Okay, so this is the one that you need to do. Okay, and then you just integrate both constant functions, and you will have this answer to be the probability. Okay, or alternatively, you may use the CDF, okay, because in this question there's no hence word. Or is there any hence word? No, right? The question simply calculate. Okay, so because there's no hence word, so it doesn't really matter. So we can use both, either PDF or CDF. So this is the alternative. Okay, in order to find the probability, okay, so you just use the CDF. So in this case, yeah, because yeah, for continuous and variable, the equal sign does not really matter. So okay, when we talk about this, okay, so in order to find probability of x greater equal 3 and less than 5, so you just take the F5 minus with F3. So okay, where can we obtain the F5? All right, so based on this, okay, so you can see that 5 is located here, and because these are all the CDF, right? Okay, so what you do is you can just substitute 5 into this function. So that's your F5. And then your 3 is here, right? So you can just substitute 3 into this function. Okay, after we obtain the values of A, B, you just replace, and then you substitute 5 into this, 1 over 2 plus x over 12, and we substitute 3 into this function, 1 over 6 plus x over 6. So you can see that it's going to be this. Okay, so this is 1 over 2 plus x over 12. So we just replace the 5 here. Okay, the x with 5. And then here, this is the value of a just now. So 1 over 6 plus x over 6, right? And because this is 3, so we just replace the x with 3. And by pressing calculator, you will obtain the value of the probability. And they have to be the same, okay, because we are talking about exactly the same probability. Okay, so these are the two different methods, okay, to find probability using PDF or CDF. Okay. Alright, okay, let's see here. We do have one question coming from the audience. Let's have a look. Okay, Phil says, Madam, katakanlah kalau X greater 4 less than 6 is also 1 over 6. How Madam nak tulis? What do you mean by this? Is it the probability or what? The probability of X between 4 and 6. Oh, okay. Oh, it's the CDF, right? Okay, macam, okay, I understand the question. Okay, so coming back to the example. Okay, so soalan Fir kata, kalau ini pun 1 over 6. Okay, kalau ini sekiranya ini 1 over 6, sekiranya probability, the PDF is also 1 over 6. Adakah kita boleh combine sama macam atas? Okay, kalau untuk discrete, yes, kita boleh. Okay, if you may refer, okay, if you refer past year. Okay, past year, macam past year yang kita buat tu, past year question, okay, number 10 kan, okay, that we discuss in class. Okay, past year question number 10, when we are talking about the PDF, okay, PDF dia, okay, because ada yang repeated kan, okay, ada yang repeated. So macam ni, untuk discrete, okay, dia punya PDF, okay, PDF dia begini. Okay, dia punya PDF untuk discrete adalah beginilah. So we just write down X equal X. Okay, sebab dia ada yang repeated. So 1 over 6 here. And then we put 1 over 2. Okay, and because 1 over 6 are repeated. Okay, so this is when for X equal negative 1. And this is when X equal 4. And this is when X equal 6. Yang ini when X equal 2. And then we put 0 otherwise. Okay, ini adalah PDF untuk discrete. Bermaksud sekiranya probability itu berulang, kita boleh je letak nilai X yang kedua dan ketiga dekat dalam baris yang sama. But now, when it comes to continuous, okay, so walaupun dia berulang, tapi kita tak boleh combine dia sebab untuk PDF, untuk continuous, dia melibatkan range tau. Dia bukannya nilai X yang countable. Macam ni X integers. So this one X are integers. So no problem. Kita boleh je senaraikan as many as possible. Okay, depending on the question lah. But now for the continuous random variable, okay, because we are talking about range. So kita tak boleh nak combine. Kita kena buat range tu one by one. Okay, so kalau kita perhatikan, ini pun 1 over 12 kan? Alright, so kalau kita tengok, sini 1 over 12. Sini pun 1 over 12. Okay, tapi saya tak gabung. Sebab apa? Sebab dia wujud untuk dua range yang berbeza. So kita just susun range dia mengikut aturan lah. Okay, so we just arrange in order. So yang mana datang, okay, yang mana yang paling kecil kita letak dulu, and then followed by this one, and then followed by this one. Okay, this one is 1 over 12, this one is also 1 over 12, but we don't combine because this is PDF for continuous random variable. Okay, unlike discrete, yes, kita boleh combine macam ni sama, okay, seperti soalan past year question number 10. So I hope that answers your question lah. Okay, so yeah. Okay, tu Phil pun kata, okay, saya baru perasan, atas pun 1/12, yes. So walaupun sama, kita tak boleh combine dia sebab ini adalah continuous. Kalau discrete, baru kita boleh combine. Okay, so now let's continue. Okay, so next, we are going to find expectation and variance. Okay, so untuk discrete, expectation variance is about sum, right? Okay, so untuk discrete, expectation and variance, okay, expectation is about finding sum of x times its PDF. Okay, again, when it comes to expectation of x squared, so it's about the sum x squared times its PDF. But now, because this is continuous, so it's about integration of x times its PDF. Yeah? So you just need to integrate. Okay, so you can see example 1. Okay, we are given the PDF. So how to find expectation? So what you do is you just multiply x with the PDF. So here you have x and this is the PDF. And this is x times its PDF. This is x times its PDF. And then we just apply the basic laws of integration. Okay, so now you need to expand first. Yeah, so x squared over 3. So integrating x squared over 3 will give you x cubed over 9. And here you need to expand as well. So you have x over 3. Integrating x over 3 will give you x squared over 6. And then this one you just need to multiply in first, yeah, before you integrate. Because this is product of two polynomials, right? So you need to expand first. So you will have 4x minus x squared over 3. So you just integrate, you will have this, and then substituting limits will give you this value. Okay, so that's the difference. Yeah? If you have discrete, it's about finding sum, but if it's continuous, okay, so you will have expectation of x is by simply the integral of x times its PDF. Okay, and when it comes to expectation of x squared also, you just change the x to x squared. So this is x squared times its PDF. Okay, and now, so this is the formula expectation of any function. So basically, you can just replace, okay, any function of x into this and you just modify the formula. Okay, and these are all the properties which I've given you in the summary. And this also applicable for both discrete and continuous random variables. Okay, so now let's say example 2. Okay, we are given this PDF, okay, for continuous random variable, and we need to find all these expectations. Okay, so first we may just find expectation of x by using this general formula. So expectation of x is simply integral of x multiplied by its PDF. So you will just bring down this PDF, and yeah, whenever you have a scalar, so my advice is, yeah, you bring the scalar out so that, okay, it will make your integration easier, so that you don't have too many terms or too many things inside the integral. Okay, so you bring the scalar out and then you just expand this one in. Okay, so you will have x squared minus x. So integrating x squared minus x will give you x cubed over 3 minus x squared over 2. So I don't really want to discuss the integration because we had done this before a lot. So you just need to know all the basic rules of integration and apply all the rules. Okay, so now, and then after you integrate, if you substitute limits, then you will get the value. Okay, why do we have to find the expectation of x? Okay, while the expectation of x is not really required in the question. Okay, because the easier way to solve all of this is just to find, okay, by finding the expectation of x, then applying all the properties of expectation. Okay, so now you see here, how are we going to find expectation of x plus 1? Okay, you can actually find the expectation of x plus 1, okay, from this formula. Okay, expectation of x plus 1 is simply by multiplying x plus 1 with the PDF that we have. But then this would be complicated. Okay, because, okay, the function is going to be long. The expression is going to be complicated and it will be harder for you, okay, to integrate. So what we're going to do is, okay, so we just apply the property of expectation. Okay, so by applying property of expectation, E of x plus 1 is expectation of x plus 1. And then by using the previous answer, you bring it down, then you add by 1. So you will get 64 over 7. Okay, then how to solve the B part? Okay, expectation of 2x. Also, alternatively, you can do this. Okay, so you can just find the integral of 2x multiplied, because this is 2x. So you can just multiply 2x with your PDF and then get the answer. And again, because this will be complicated, okay, because we already have the expectation of x, so we just make full use of it. Okay, so or you use the property. So, okay, by taking the 2 out, so it's just 2 times expectation of x, and bringing down the previous answer will give us 114 over 7. And then next, okay, expectation of 10 minus x. So again, okay, what you can do is finding the integral of 10 minus x times its PDF if you want. But again, okay, I don't really advise you to do this because it will get complicated, yeah. Okay, so what you need to do is you just find the expectation of x, and then by using the property, yeah. So by using the property, so you will have 10 minus expectation of x, and you bring your previous answer down, so you will get 13/7. Okay, and then lastly, for this D, how to find expectation of 3x squared minus 5? So by using the property, okay, so we have 3 times expectation of x squared minus 5. Because we don't have this one, okay, so you can just find this by, okay, using the formula. Okay, expectation of x squared is simply the integral of x squared times fx. Okay, and then you will get this value. So you bring it down. Okay, then this would be the answer. Or, okay, again, if you don't want to use the property of expectation, you may just find this expectation of 3x squared minus 5 by integrating, okay, 3x squared minus 5 multiplied by the PDF that we have. Okay, and yeah, expanding the bracket and okay, integrating the function, substituting limits will give you exactly the same answer, 1289 over 14. Okay, so that is how to find expectation, okay, for continuous random variable. Okay, then variance also, when it comes to variance, the formula is just the same with discrete, okay, because variance is just expectation of x squared minus the expectation of x squared. Okay, but okay, when it comes to the expectation themselves, we apply different methods. Okay, again, because when it comes to discrete, finding expectation is about finding the sum, while for continuous, finding expectation is about finding the integral. Okay, so now example 1. Okay, so how to find the variance? Okay, first you just find the expectation of x using this formula, and also expectation of x squared using this formula. And please bear in mind, because we do have two different functions, okay, so that's why we need to have two different integrals. So I would advise you, okay, as when you get the continuous random variable question, so always have, okay, number line, because you can see clearly the different functions defined for different regions. So you can see between 0 and half, and then between half and 1, you have two different functions here. Okay, so this first function is 4 over 3 times 1 minus x. And for the second function, okay, and then circle here until 1. So we have this function 4 over 3x. Okay, so now finding expectation of x. So you just multiply x with your PDF here. Okay, the first function. And then x with the PDF here. Okay, don't forget to expand first before you integrate. And this one also expand first before you integrate. Then after you integrate, substitute limits, and this will be the value. Okay, this one also x squared times its PDF, x squared times its PDF. And again, okay, don't forget to expand here before you integrate. This one also expand before you integrate. And then, okay, after you integrate, substitute limits, then this would be the expectation of x squared. Okay, after we find the expectation of x squared and expectation of x, so it's time to substitute into the formula to find the variance. Okay, and also the properties of a variance here applicable for both discrete and continuous. All right, so this is the second example. Okay, so x is a continuous random variable with PDF. Okay, and the PDF is not given, it's just that we are given this information. Yeah, okay, so we are given that the integral of x squared times PDF is equal to 29, and the variance of 3x is 36. Then find the mean of x. Okay, how are we going to solve this problem? Okay, you don't get panic. Okay, even though we are not given the PDF, but okay, we can just make full use of all the informations given. Okay, now have a look closely here. This is x squared times its PDF. So you can see that x squared times its PDF is basically what? This is basically expectation of x squared. Okay, so this is basically expectation of x squared. So now, okay, so this is the first information. And second information, we are given variance of 3x is equal to 36. Okay, so we can see here variance of 3x is equal to 36. And not only that, by using property of variance, okay, so again, variance of a constant is 0. Variance of a scalar multiplied by x is the scalar squared times variance of x. Okay, now because we have variance of 3x, so if you want to take the 3 out, so you need to square the 3. So that's why it is 9 here. So you will have 9 variance x equals 36 and your variance x equals 4. Okay, now we have got two informations here. And the question says, find the mean. Okay, so find the mean means find the expectation of x. Alright, so now what do we do? Okay, because we have got this value and we have got this value. Okay, this one is unknown. So you just substitute the value of variance x into the formula, expectation of x squared into the formula, and you just make this as a subject. And the mean is going to be this answer. And again, I just need to remind you, mean can be both positive or negative. Yeah? Let's see the summary. Okay, so for discrete and continuous, when it comes to the mean, it can be both positive and negative. Okay, but when it comes to variance, okay, standard deviation, we must get positive answer. Okay, so that's the difference. So once you get the mean, okay, so you don't really have to worry if the value of mean is negative, because okay, the mean can be negative value. Yeah. Okay. And then okay, let's see the last example for today. Okay, so example 3, the continuous random variable x has okay probability density function. So this is the PDF. Okay, so this is PDF of the continuous random variable. Okay, so we are given the expectation or the mean as mu and the variance as sigma squared. So the question says find the probability of absolute. So this symbol is not magnitude, it's not modulus, nor it's not okay determinant. So this is absolute. Because why? Because we do have real numbers inside. Yeah. Okay, so now find the absolute of x minus mu less than sigma. Okay, so what do we do? Okay, first we just find the mu. The mu is expectation, right? So by using this formula, okay, so we just multiply x with its PDF. We expand first. Okay, we expand x times 1 is x times x squared is x cubed. Then only we integrate. Okay, don't simply integrate before you expand. Okay, because this is a product of two functions. Okay, so you need to expand first, simplify before you can integrate. So integrating x will give you x squared over 2. Integrating x cubed will give you x power 4 over 4. And then by substituting limits, you will get this value. And same thing also we do for expectation of x squared. Okay, expectation of x squared is simply the integral of x squared multiplied by its PDF. And here you have this x squared and this is your PDF. So first expand in. Alright, so x squared times 1 is x squared times x squared is x power 4, and then only you integrate. So integrating x squared will give you x cubed over 3, integrating x power 4 will give you x power 5 over 5, then only you substitute limits, you will get the value. Okay, then what is the purpose of finding these two measures? Okay, why do we need to find the mean and expectation of x squared? Because okay, we need to find the sigma, right? Okay, the sigma. Okay, so first we substitute these two into the variance. So sigma squared is the variance. And the formula is expectation of x squared minus expectation of x squared. Okay, so now after we get the expectation of x squared, 2 over 5, you substitute here. And then expectation of x, which is the mu, 9 over 16. Then don't forget to square it. So this is the value of the variance. Okay, so now how to find standard deviation? So standard deviation is simply sigma and it's simply square root of variance. So okay, after we obtain the value of the variance, you substitute finding the square root of it. So you will get the value of sigma to be 0.289. Okay, we are not done yet because okay, the question not only asks us to find the mu and sigma, the question asks us to find probability of absolute of x minus mu less than sigma. So because you can see the symbol of absolute here, which means we need to apply the property or the definition of absolute. Remember, okay, absolute of x less than a. So we're going to apply the law definition. Okay, so it's x less than a intersect with x greater than negative a. So combining these two back will give you x greater than negative a less than a. So this is the definition of absolute value using the law. Okay, if it's a goal greater than, so the definition is going to be x greater than a or x less than negative a. So this is if you have the greater than sign lah. So this is the goal. Okay, always remember is the goal lah, greater or less n. So because this is less n, so we simplify it to be this region. So x greater than negative a less than a. So this is it. By using the definition, you have x minus mu greater than negative sigma less than sigma. And then by moving the negative mu to the right and to the left, so you will have negative sigma plus mu and sigma plus mu. So you need to find the probability of x between 0.2734 and 0.8516. And because for this particular example, we don't have CDF, so we cannot use the CDF to find the probability. So what do is we just use the PDF to help us to find the probability. So again, for continuous and variable, finding probability is actually finding the area below the graph. Okay, so it's between this and this. So you just integrate the PDF. Okay, so this is your PDF. And then from this lower limit until this upper limit, and you just integrate the function, substitute limit, and you will find the value is 0.583. And again, okay, whenever you find the probability in this topic, it has to be less than 1, because the concept of probability is it has to be between 0 and 1. Okay, so guys, okay, that wraps up our topic 9, okay, and which means, okay, we have now completed topic 9. Okay, so topic 9 is now covered. So you can start finishing all the tutorial and past year questions. Okay, so any other question? I can't see any from the left chat. So that means that's the end, okay, for today. So I end our lecture with Assalamualaikum warahmatullahi wabarakatuh and have a nice day. Thank you for your attention. Thank you for your presence. Bye-bye. Have a nice weekend, everyone.